All right, good morning, happy snow day. Here's Here are answers to this the 8-0 more practice that you could have done optionally. You may have some questions about it. I just want to hit a couple of highlights here. Um, when we're talking about radicals, you got to get this perfect square out of it. So the square root of 99, if we break that down, we could figure out that it's equal to 9 times 11, or we could say it's equal to the square root of 3 times 3 times 11. What comes out of that? The square root of 9, or the square root of 3 times 3 is equal to 3, and then the 11 cannot come out. When you have an expression like this, the numbers that are inside the radical can multiply with the numbers inside the radical, so that becomes the square root of 300. 5 times 60 is 300, which you can then simplify down to 10 square root of 2. If you have numbers on the inside and numbers on the outside, what you do is you can multiply the numbers on the outside. There's an implied 1 over here. 1 times 4 is 4. And then 6 times 24 is, what is 6 times 24? It is, seriously, what is 6 times 24? 144. The square root of 144 is 12, so this becomes 1 times 12 is 48. All right. Seriously, have questions about these, you can email me or something, but we'll do the best we can. When you have the quotients, always simplify first. On number 5 here, or number 13, there were two ways you could do number 13. You could have just jumped straight into this and you had the square root of 2 over 10 and start multiplying by the square root of 10 over the square root of 10. Remember, that's how we rationalize the denominator. We get the square root of 20 over 10. Then we'd have to simplify the square root of 20, which is 2 square root of 10 over 10, which then finally reduces, the 2 over 10 reduces to square root of 10 over 5. So that process right there, we had to multiply the square root of 10 over 10 to get rid of the radical, or the denominator in the radical. Square root of 2 times the square root of 10 is the square root of 20. The square root of 10 times the square root of 10 is 10. Simplify the square root of 20. That becomes 2 square root of, no, it's not square root of 10, 2 square root of 5 over 10. Come on now. 2 square root of 5 over 10, which the 2 over 5 that's on the outside reduces. So we end up with square root of 5 over 5. It would have been much simpler to have taken this sucker and reduced it from the start. 2 over 10 is equal to 1 over 5. So always reduce whenever possible. Now we just multiply by the square root of 5 over the square root of 5. The square root of 1 times the square root of 5 is the square root of 5. Square root of 5 times the square root of 5 is 5. And you just get the answer so much quicker and easier. So reduce whenever possible, like you could have done on number 12. Could have done a number 16, cross-canceling could have happened, but just always reduce. The other key part of it is to multiply by whatever's on the denominator. I don't have the other side of this page done for you, which I apologize, but just remember if you're adding, let's just say you're adding the square root of 12 plus the square root of, let's see, 27. You simplify both terms. Let's make it a little bit more interesting. Let's make it 5 square root of 12. So it becomes 5 times the square root of 12. Square root of 12 becomes 2 square root of 3. Square root of 27 is 3 square root of 3. 5 times 2 square root of 3 is 10 square root of 3 plus 3 square root of 3. Now we can combine those like terms. 10 square roots of 3 plus 3 square roots of 3 gives you 13 square roots of 3. With addition and subtraction, you're combining the like terms. They have to be the same radicals. You oftentimes have to simplify before you can do that. So there was your review on radicals. What I expect you to do is to close your books and take the quiz that's attached as well and do the best you can. Please turn that in to me tomorrow, Tuesday.